Hello, ladies and gentlemen, and a very warm welcome to MyPV's first webinar on THOR. THOR is our latest and newest solution to create hot water from photovoltaics. We are presenting the new DC power manager from MyPV named THOR. My name is Reinhard Hofstetter. I'm responsible for product management, and I'm very happy that you are participating this webinar. I'm at MyPV for already more than 8 years, and before I started at MyPV, I was in the field of research and development of solar thermal systems. So I was used to work with pipes and thermal collector systems, and from that background, we know that these old-fashioned conventional solar thermal systems are actually out of time. So there is a better way, an easier way, and a cheaper way to create hot water from photovoltaics, and this is by the THOR, for example. And the idea is not completely new. Gerhard Rimpler, the founder and CEO of MyPV, started with the very first DC product more than 10 years ago. And Elva, as you see it in the background here, is still part of our portfolio. Another person I would like to introduce to you, ladies and gentlemen, is Alice Kramolishova. She's our colleague and she's responsible for international sales. And Alice is also in the webinar room with you together, and she's available for questions anytime. So while I'm talking and while I'm presenting the slides, you can enter your question in the chat window on the right. One more hint on our presentation. Of course, you are going to receive the slides of the webinar afterwards. So I'm going to send you an email with the content of the slides today. Okay, first things first, here's a short overview of our history. And actually, the whole story as a manufacturer began in the year 2013 when MyPV developed and started the production of a product named ELVA. The abbreviation ELVA, nothing else means than electric water heater. It's that easy, an electric water heater, but it is an electric water heater that can be combined directly or directly connected to PV panels. That's the big deal here. And during the years, there was the invention of several AC products. And this is not the topic of today. We are going to deal with the latest innovation here. It's THOR. And I was talking about ELVA because THOR is basically similar. It's also a DC solution where we connect PV panels directly. What is the purpose of ELVA and THOR? It's about doing the hot water heating. So this is our headquarters in Upper Austria. Here is our office building and our production building. And last year, we increased the production capacity by a factor of 20. So the whole topic of hot water from PV panels is really something that is an amazing trend right now, especially in the last 2 years, because it helps you to more independency. And that's simply the goal for many customers we have. All right. We are doing hot water heating with an electric heater, but we are not doing it in the way as it is shown on the top half of the slide here. We are not using energy one by one from the grid. This would be a waste of energy. It would definitely be not economical in Europe, and it will probably would not be very eco-friendly because there is also fossil power in the power grid. Fossil energy. So what are we doing then? We are working according to the principle below. We have an electric heater, that's right, but we are using PV power for heating. And in case of ELVA and THOR, we are using it directly without an inverter in between. So you connect the PV panels to our device and you connect the immersion heater like this on the other side, and your hot water system is ready. what is always an option for all our MyPV solutions is to use grid power as a backup source. You need backup, for example, when there are some cloudy days or days with bad weather conditions or during wintertime. But basically, this is an option because, of course, the backup can also be done by a conventional heating source, by a heat pump, by a biomass boiler, by a district heating system. This does not matter to us. Of course, this hot water boiler or this thermal tank can also be heated up by a conventional heat source beside our solution. And to do so, these two heating systems, they do not even need to communicate with each other. They are independent from each other. They are just heating up the same tank. All right. So grid power is an option. What you can use it for is, for example, to deactivate your conventional heating system during summertime, and you save the lifespan of this system because you can take a few kilowatt hours from the public grid for backup if you like, but you are not forced to do so. All right, DC solution. Here is what we are talking about. It's the THOR. And to start with the THOR, I would actually talk a little bit of ELVA in the first step. So here comes the ELVA. It's a DC immersion heater. And on the heating element, there are also the power electronics, which is the core know-how from MyPV. And this power electronics in here, they ensure that the power output on the immersion heater is adjusted linearly. And it's possible to do this with ELVA from 0 to 2 kilowatts. And every single watt in between is possible, 0 up to 2000 watts. And this is essential to use PV power because the solar yield from the panels, it's changing permanently. Clouds are moving on the sky and the irradiation from the sun is not constant. And we are adjusting the power output very precisely according to the solar yield. Beside that, there is also an MPP tracker integrated. In that way, we ensure that it's working really efficiently. You probably know the term MPP tracking. It's an element from a PV inverter. So here we do not have a PV inverter, and that's why the ELVA is taking care of the MPP tracking. On the bottom side, we have multi-contact plugs, MC4 plugs, and these are standard plugs that are also used on PV panels. The ELVA is supplying itself, its internal consumption, from the DC side. So it's possible to use it completely off-grid. Yeah, it runs on the DC side alone. It also works in remote off-grid systems, and it also works during blackouts. Very important. So this European mains plug here for the AC backup is the option I was talking about. It's not even necessary to plug it into the socket. And if you do so, then the AC backup is used. For the ELVA, by the way, last detail on this product, the AC backup power is 750 watts, while the DC linear control power is from 0 to 2000 watts. Yeah. Okay, and we started with ELVA more than 10 years ago. And now it's about the next step that we are going to do. Think about a situation you might have. Think about a hot water boiler where there is already a heating element integrated. For example, a standard immersion heater like this. It's on or off and not very smart. So that's it. And you do not want to replace it because you do not want to change anything on the hydronic installation. What can you do? So far, you were not able to do anything when you want to connect it with solar panels, but in the future, you can use the THOR. The future is quite near. The THOR is available in the first trimester in the next year. So basically, THOR does the same as ELVA. It's a power stage. It's adjusting power output, and it's doing MPP tracking as well. But the immersion heater is not permanently integrated. It can be wired, and you can use a third-party immersion heater with it. So question comes, why can't we connect PV panels directly to a heating element like this, to a standard heating element? This is a question that comes quite often. Actually, I understand this question because this is what we have learned in the physics school. Yeah, we have a voltage source and we have a resistive load on the other side. You can connect it, but you can only connect it on the table of a laboratory. So when we are talking about PV power with up to 3.6 kilowatts, it's not that easy. So why do you need a solder in between your PV panels and the immersion heater? There are 3 reasons for this. Number one, it's about the efficiency. I already mentioned the MPP tracking. That's the reason why you need a solder in between. Otherwise, it would be a waste of energy. Second and third are reasons regarding the security. Number 2, the solder has an ISO fault detection, which means if you have a short circuit on the DC plus or the DC minus, it can be detected by solder, and then it deactivates the system. This is an element, an essential safety feature that is required. Otherwise, you have DC power somewhere in your building. All right. Okay, and reason number 3 is also a safety reason. It's not possible to deactivate an immersion heater with a thermostat like this when there is direct current on the switch. Imagine what happens when you have direct current on an AC switch. When the switch opens, you have a light bow, an arc in between, and this arc will destroy the switch. In the worst case, it can cause a fire. So, 3 very important reasons why you need solder in between the PV panels and the immersion heater. Do never ever connect panels directly to the heater. It's about your own safety, okay? So, second advantage. Here's an example, ladies and gentlemen. This is what happens when you disconnect direct current, this DC, with an AC switch. Yeah, it's really a safety issue. So, second feature of solder, the power range. While the ELVA was able to adjust the power output from 0 to 2000 watts, solder can do much more. It can adjust the power output from 0 to 3.6 kilowatts. Yeah, for European conditions, there is probably no immersion heater with 3.6 kilowatts in the project available. Mainly, we are talking about 3 kilowatt immersion heaters like this or lower, and they can be connected to the solder, of course. So why is there this huge power range? To be honest, it's about the Australian market. So the Australians, they have more voltage in their grid than we Europeans do. They have 240 volts in the AC grid, and we have 230. So more voltage means more power, and for the Australian, this means that they can use a 3.6 kilowatt immersion heater, even when it's a single phase immersion heater. All right. But of course, it's not a problem at all to connect an immersion heater with less power to the solder. It will automatically detect the nominal power of the load. You do not even have to change a setting there. And when you choose a MyPV immersion heater as an accessory part for solder, of course, you are allowed to cut off the European mains plug here. Yeah, this has no influence on the warranty. All right, next big deal for the DC ELVA, for the gray one, it was possible to connect 10 panels, 4 to 8 panels, linearly. And the range here for solder is much bigger. Up to 10 panels can be connected. When we are using 10 panels, it actually means that there are 2 times 5 panels in parallel. So here on the bottom, you see the multi-contact plugs. There are 2 inserts and 2 outlets for DC wiring. And I skipped 2 slides, so I need to go back a little bit. While I was talking about the power output, I already mentioned that you can use the MyPV immersion heater here as an accessory part. But actually, as long as it is a single-phase immersion heater and it has a thermostat integrated, you can also use third-party heaters here. What else? You can also use standard electric boilers. These are very common forms for hot water heating, let's say in apartment buildings, for example. And you see the DC plus and the DC minus wiring is always on the solder, and it's supplying itself from the DC side only. If you choose to use the optional boost backup, then you need a wiring on the AC side as well, but only in that case. So for the normal system, you can choose as a conventional heating system for backup. You can see there is a heat exchanger symbol in here. So there can be a biomass boiler or whatever connected, or you use AC backup. When you have one of those standard electric boilers and they do not have the integration of a conventional heat source, of a hydronic heat source, then you probably always need the AC backup to ensure the temperature at any time, also during nighttime. All right, you can also use 2 immersion heaters, and Soltor is able to control the power output on them both, but not simultaneously. So first, the Soltor will adjust the power output linearly on the heater and on the top. And then when the heating here is finished, it changes over to the heater at the bottom and does the linear power control here. And one hint at this point, actually these 2 immersion heaters, they can also be in 2 different tanks. One can be in the hot water boiler, one in the storage tank. It does not matter. The AC backup, anyway, is just possible on the heater that has priority. So the heater on the top here in this schematic. Why is that? Good question. It's because in that way we ensure that the bottom side of the tank always is free for remaining PV power. So we are not going to block the boiler here with power from the grid. There's always a chance to have solar power for the heater. All right, this immersion heater from MyPV, it's an accessory part that actually is available for many years for AC products named Actor and Actor 9S. But actually, the single-phase variant with 3 kilowatts can also be used for Soltor. And you cut off the mains plug here, and then Soltor can adjust the power output from 0 to 3 kilowatts. All right, then we already talked about the panels. Even one panel is possible. So imagine what that means. You have an apartment building with a small balcony, for example. You can use 1, 2, or 3 PV panels. And then I'm talking about standard panels. I'm not talking about those AC balcony power plant panels. We are much cheaper than by using standard panels. You can do so if you like. Next big thing for the Soltor is the protection class, IP54. That's a big deal because so far all the other MyPV products were designed for indoor installation. And that's not the required anymore for Soltor. So you can install it outdoor on the outside of your building because it's resisting dust and water, of course. What is not recommended from our side to have it directly in sunlight. But if you assemble it below the panel or you do some shadowing above, then we are absolutely fine with the installation, even outdoor. Okay, at this point, I would like to show you a short video, and movie comes.
The THOR is a DC power manager for solar electric heat generation. Thanks to its autonomous functionality, the THOR does not require a connection to the power grid as the device is self-supplied by the PV generator. The THOR also scores points for its simple installation. The photovoltaic direct current power manager is simply hung in the supplied wall mount, while the heating element is installed separately in the heat storage tank. This means that existing heating rods in heat storage tanks can be controlled with THOR. With a control power of 0 to 3.6 kilowatts, the THOR now delivers even more power for your heat generation. Solar power is efficiently utilized by being transferred almost loss-free from your photovoltaic modules to a connected heating element. In addition, 2 heating rods can be alternately controlled. The THOR can be flexibly used with a variable number of modules between 1 and 10. This broad scalability allows adjusting the THOR's performance to the specific requirements of your heat demand. Additionally, 2 module strings can be connected in parallel, allowing for a total input current of up to 26 amps. The input voltage range extends from 20 to 230 volts. The waterproof construction of the THOR withstands any weather conditions, making outdoor installation possible. Even the display is designed for outdoor use. The color touch display offers an intuitive user interface through which all important functions can be read. The commissioning and operation of the device are therefore remarkably simple and intuitive. For more information, please visit our website.
Empowering the solar future.
Yeah, this was an example of a very, very typical Austrian off-grid installation. Actually, the THOR can be used in desert areas or in the jungle or wherever you like. And the guy who was playing the instrument at the end is actually a colleague of us, who's very much involved in the R&D of THOR. All right. Next slide. There are more benefits than those I already have mentioned. It's not required to have an approval from the grid operator because the THOR is not on the grid. When you connect the AC side, it's just taking power from the grid as a load. It's never feeding back into the grid. It is not a PV inverter, to be clear. And maybe this is a good point where I can answer this first chat question. The THOR output is not AC sine wave. It's some kind of AC because, as I explained, you cannot power an immersion heater like that with DC power. It's some kind of AC, but it's definitely not an inverter. You cannot supply AC loads with the THOR. Please never do so. Okay. We have seen the schematic. So stratification charging is possible with 2 heating elements, one after the other, can be controlled linearly. And optional hot water backup is always available. Thanks to the display, there is an easy way to operate it and to do the installation. You definitely do not need any other items to do the setup. Even the first setup, it's not necessary to have any other tools on site, except the hardware tools for the wiring, of course. Yeah. Maintenance free due to cables instead of pipes. That's one of our core philosophies. Always in comparison to solar thermal systems. You do not have an anti-freezing liquid or something like that, which you have to check once a year. Yeah, and the whole problem with evaporation and stagnation of thermal collectors, it all disappears. Yeah, you just have PV power, and when you do not take the power from the panel, it does not harm the panel itself. So you do not have any negative effect on the materials when you do not need the power, because of course there are times where the power from the panels is not used. When the hot water boiler is on target temperature. This is the point where the THOR shuts down, and then the remaining PV power is unused. It is a question of the dimensioning. For a 4-person household, we recommend 2 kilowatt peaks in Central Europe. And with this dimension guide, and there is a diagram in the data sheet, by the way, you can avoid that there is too much current unused. There are hardly no solar yields unused. It's all within the 1-digit percentage range. We know from apartment building projects that there are 6, 7, maybe 8% of the theoretical solar yield that remain unused because the heating is already done. So question comes, isn't it wise to have an inverter then for this remaining power? No, not in that case. If you want to use everything, and if you also want to combine it with a battery, ladies and gentlemen, then check out our webinars on the AC products. Here you can use all of the energy for the house, for the appliances, for the battery. You can send energy back to the grid, but these are AC products. So I would like to focus on that if you want to know if you can combine it with batteries and so on. This is not the case with Soltor. It's a standalone DC solution, and it's using all the energy for heating only. Yeah, and using wires instead of pipes, of course, the whole installation becomes much easier. And in that way, it's more affordable than conventional water heating. And above that, of course, our energy source, our primary energy source that we are using is renewable and endlessly available. It's the sun. So, of course, it becomes cheap in that way. I already told you, you do not need any other software tools to do the commissioning. Anyway, the Soltor has communication interfaces available, so you can use a local area network or Wi-Fi if you want to check out what the Soltor is doing. And in that way, you can also connect it to the MyPV data cloud. I'm going to show you later. Technical details. So power range from 0 to 3.6 kilowatt theoretically. Depends on the heating element. So actually you can use smaller immersion heaters as well. The DC input voltage is something you need to know. It's between 30 and 230 volts. So 1 up to 2 up to 10 panels is possible, but for 10 panels we are talking about 2 times 5 panels in parallel. Otherwise, we would exceed this top level of the voltage here. So the input current is limited to 26 amps. More current, if it would be available from the panels, would not harm the Soltor. Only too much voltage can harm the device, so please always consider that. The AC operations, I already mentioned it, I think 100 times, is optional. But once more, it's possible to use it if you want to do the backup with grid power. You can set 2 time frames. You can adjust these time frames for separate days during the week if you like. And in any case, it is single phase. It's a single phase product. Yeah. Grid independent standalone solution without inverter, protection class for outdoor installation. And there is also an external temperature sensor included in the scope of delivery. Actually, you do not need it anytime. For example, when you have a thermostat on the immersion heater which cuts off the load, it's we are completely fine with it. And in that case, I'm sorry, ladies and gentlemen. And in that case, you do not even need to install the temperature sensor. All right. After the webinar, I'm going to send the data sheet. And here is a link. I'm going to send the slides of the presentation. And here is the data sheet in the link here. All right. What are the advantages over solar thermal systems? There is an easy installation on the electrical cables, and it's not required to do any piping. So wires instead of pipes is our benefit. There are virtually no losses between the PV generator and the heat storage, because on the wire you do not lose any energy or hardly no energy. And it's maintenance free because there are no moving parts and no anti-freezing checks are required. There is a higher yield from PV modules, even at lower ambient temperature, and that's, of course, a huge benefit compared to solar thermal systems, because the colder it gets in the ambient air, the lower is the efficiency of solar thermal systems. And here with PV heating, it's the other way around. That's the cool thing here. Yeah, no stagnation issues, and in the morning the device restarts automatically. Soltar in residential constructions for apartment buildings, we see many advantages here. And this is due to the fact that we have decentralized hot water heating. So we can use solar power or solar energy directly at the point of use in the apartment, and we do not lose anything on the transmission line. Yeah. A hydronic system would mean that there is a ring main pipe which pumps hot water 24/7 to every apartment, and this is not required anymore, because on these ring main pipes you use megawatt hours of energy during the whole year, and these are losses that are completely avoided here with wires instead of pipes. We already know from apartment building projects with ELVA that the solar coverage rates are very high, sometimes 70 to 80% in Austria, which is pretty good. So only 20 to 30% of the energy that is required for hot water heating comes from the grid. That's really a good performance here. Decentral small electric boilers, they also meet the hygienic requirements in Austria and Germany, for example. You do not have to do the thermal disinfection of the water. And of course, there is no grid access permit required, because the Soltar is not an inverter. It cannot send energy back to the grid. Yeah, and the whole installation effort becomes smaller by using wires instead of pipes. And in an apartment building, it's also possible to use standard PV panels on the balcony, for example. Yeah, the MyPV Cloud is an portal, an online portal that was so far only available for the AC products, AC Alpha 2, Actor 9S. But for the Soltar, it will also be possible to include the device in there. What is the MyPV Cloud? It's not a smart home system. So it's not the purpose here to control your home entertainment system or whatever. It's just to visualize MyPV devices. So the end customer always know from every area of the world what the device at home is doing and what temperature he has in the boiler, for example. For the installer, it also offers advantages because he can add all the devices of his clients in the cloud. And he can check it from remote, so also from his office if he likes. This whole service is for free. It's not an app. That's very important, because here there is also the screenshots on mobile devices. It's not an app. It always is used by the web browser, also on smartphones. And it's just a visualization of the MyPV devices. It's not a smart home system. It's not a home automation system, and it does not control other devices in your building than the MyPV devices. All right. More information on MyPV products and the Soltar, of course. You find them anytime in the download section of our website. So far, there are just marketing videos and the data sheet online for Soltar, but over the next weeks, of course, we are going to provide manuals and wiring diagrams step by step, and it will all be ready and available when the Soltar is shipped to our customers. Yeah, how can you buy a Soltar? We have a quite good developed distribution network in Austria, Germany, Switzerland, and Alice and her colleague are working very hard to increase this distribution network also in other areas. For example, in the UK, France, in Spain, in Italy, there are already wholesalers cooperating with us. And Alice is, of course, the contact person for you if you're interested in a SOLTOR or if you are interested in the cooperation regarding distribution activities. Okay, finally, our products, your benefits. We see that, in summertime, it's possible to have 100% of hot water by the SOLTOR. Nearly 100 if you only use the DC side, but 100 if you use the optional backup as well. It gives you the chance to lower your operating costs, because for every kilowatt hour that is sent by the SOLTOR in your boiler, you replace a kilowatt hour from, let's say, natural gas, for example. So it's definitely saving operational costs, and it's definitely also saving the lifespan of the other heating system. And for all MyPV products, it's essential to know that it's all about linear power control. This is what we are doing with our solutions on resistive loads. Forget everything that is just switched on and off. An immersion heater like this is not PV ready. It's on and off, nothing in between. When you combine it with a SOLTOR, then it's PV ready. Then it's adjusting the power output linearly by SOLTOR. That's the essential reason to install MyPV solutions. All right, ladies and gentlemen, we are now at the end of our presentation. I would like to thank you very much for your time, and wherever you are, all the best from my side, and we are looking forward to a good and brightful cooperation with you. All the best from my side here in Upper Austria, and goodbye.
Empowering the solar future.